Today we're going to be talking about growing media components. Berger pays attention to every detail in order to provide high quality products, which include all the components that are used to produce the growing media. Whether they are produced by Berger or supplied by a manufacturer, all these ingredients are submitted to rigorous quality control. The important thing is the fact that each component in that mix has to complement the other. Okay, and so we do go through a rigorous quality control to make sure that each component will interface well with the other to form actually aggregates, which then in turn creates the pores for water and for aeration. Growing media components. Numerous ingredients can be added to peat in order to create a specific characteristic in a growing media. The main components added by Berger are perlite, vermiculite, pine bark, wood fiber, redwood, cocoa coir, compost. Perlite, volcanic glass with high water content, expanded by intense heat. Here we have two pictures showing the raw ore and then what it looks like after it has been popped under the high temperatures. Volcanic glass with high water content expanded by the intense heat then results in what we call the popcorn look or rounded perlite, which then is ready to be used as an aggregate in the mix under very high magnification. As you can see, there is a lot of pits and cavities in here to hold some water at the same time to also hold some air. Okay. As far as water content, it's not as high or even near the content of peat or other organic components, and the main purpose of it is an aggregate to increase the drainage. It's an inert chemical, low conductivity, physical characteristics, low density, high porosity. As you can see again, airspace of 50 to 65% created by the craters. It's clean, it's sterilized by heating. Added to increase porosity, usually the amount added is between 5 to 30%. At Berger, perlite is expanded in our factory. Perlite dust is removed before expansion. Perlite sand is removed after the expansion. And we end up with an expanded perlite, which is sieved and separated into fractions, fine and horticultural. Fine being used in our germinating mix, the horticultural being used in our regular standard mixes. Perlite production is submitted to quality control, particle size, expansion factor, yield, and brittleness. So in this case, we're wanting to make sure that we have more of a homogeneous sized particles going into the pot for consistency, and the yield and the brittleness. So we want to make sure that it has integrity in it so that it's not breaking down, especially during the mixing process, even at the greenhouse site. As there are no residual small particles in our perlite, the added percent in our mix is a true percent content. Vermiculite, okay. Silicate mineral with high water content, again expanded by heat. As you can see, the raw material, more of a shale looking type material. Once it's expanded by the heat, then we can see the chemical characteristics, and as you can see, the platelets in between the expanded ore, which serve as sites for holding on to nutrients. So it does have a high CEC, 100 to 150 milliequivalents per 100 grams. Low conductivity, so very low EC or salt content. Physical characteristics, low density, high porosity, airspace 15 to 55%, again created by the openness and pockets in between the platelets. It's clean due to the fact that it's expanded by intense heat, so it is cleaned, it's sterilized by heating. Added to increase water and nutrient retention, usually between 5 to 25% content in several mixes. At Berger, vermiculite is expanded at our factory just as perlite. Dust is removed from the raw vermiculite. Dust is removed from the expanded vermiculite. Expanded vermiculite is separated to produce our fine and horticultural grade vermiculite. Fine going into our plug mixes, such as the BM2 line of mixes, and then the coarser grade going into a mix such as BM1. Vermiculite is also submitted to the same strict quality control testing as the perlite. As there are no residual small particles in our vermiculite, again, the added percent in our mix is a true percent. Pine bark, forest industry residue, used fresh, aged, or composted. Again, chemical characteristics, depends on decomposition rate. Physical characteristics, medium to large particle size, depends on decomposition rate and the sieving process. High density shipping cost is higher if we were to compare it to the very light perlite that we do use as an aggregate. Okay. It is stable. Added to improve drainage in long-term crops, usually between 25 to 45%, but up to 100%. At Berger, 2 different types of pine bark are produced. We have aged bark, BKN, northern bark, and composted BKS, which would be the southern bark from down south. Okay. Piles are closely monitored and managed. Temperature is monitored. They are covered with a specifically designed tarp to protect them from contaminants and preserve their quality. The quality of the bark is tested before each production. The bark is sieved with a star screen system. Wood fiber, produced with forest industry residues. Different methods produce different fibers. As you can see here, here's more of a pictorial process showing you the debarked sapwood, chipped, going through the augers, and then the final defibering process. Chemical characteristics, it's stable, depends on manufacturing process. Increased wettability, it is hydrophilic, so it does love water instead of repelling water as peat moss would. The pH is around 5.5, pretty stable pH. Physical characteristics, really low density. So again, a nice aggregate to add, doesn't add a tremendous amount of weight to the mix. Easily compressed, so fits right into our compressed format products. Clean, depends on the manufacturing process. Added to increase porosity and easily available water. 10 to 30%, above 30%, we did notice some nitrogen immobilization started to become an issue. Wood fiber at Berger, first to use this material in America, manufactured from residual material from local lumber industry. Every load is submitted to rigorous quality control testing. For a given packaging, the compressibility of the wood fiber allows Berger to provide growers with more yield per unit. Redwood, Sequoia. Forest industry residue which is chipped, aged, and then sieved. Again, a pictorial little chronologue of basically comes in this case, they're actually debarking and using the bark and not the sapwood. Stored, and then they start to process it and at the plant in Sunland. So forest industry residue, chipped, aged, and then sieved, its chemical characteristics, stable if aged properly, between a pH of 4 to 5. Physical characteristics, several grades are available. Low water retention except for the fine grade. Fairly high density, added to increase porosity and added weight to the substrate, usually between 20 right up to 100%. At Berger, the Redwood Sequoia is only available at with Sunland products in California. With the involvement of Berger, quality control has been significantly improved at the processing plant at Sunland. Redwood grades are submitted to particle size and SME testing. Piles are monitored weekly. Coir, produced from coconut husks. Chemical characteristics, high levels of potassium, sodium, chloride must be treated. Moderated CEC, 50 milliequivalents per 100 grams. Stable with just a slight nitrogen immobilization. Increased wettability, so again, hydrophilic. Physical character. Particle size is variable, fine, fibers, chunky, etc. High water retention, 8 to 9 times its dry weight. Low density, added to increase porosity and water retention, 5 to 100%. It reduces the need for a wetting agent. And again, it reduces the need, but there is still, because many times it will be added to peat moss, there is basically still a portion of a wetting agent that has to be added to stabilize the peat moss. Coir at Berger uses only treated coir of the highest quality. Also submitted to a quality control upon reception. As Berger produces its mix with dry coir, growers can benefit from an increased volume if they adjust the water content before potting. As it is mentioned, treated coir, so it has gone through several good waterings to try to reduce the higher EC content, to try to leach out some of the high potassium and some of the high chlorides. So it is definitely treated, and so it's coming to us at least with some quality control, and then we submit it for further quality control. Compost. Residues from several sources. It has to reach high temperatures to mature properly and to be used safely. Chemical characteristics. Contains nutrients. pH is around 7 if composted properly. And the composting process is monitored on a daily and weekly basis to make sure that we have achieved the proper pH. Physical characteristics, very high density, small particle size, high water retention, added to increase water retention and provide nutrients that are slowly released, between 5 to 20%. Compost at Berger is produced always with the same sources of nitrogen and carbon. Piles are monitored throughout the composting process. Temperatures, CN ratio, which is the carbon to nitrogen ratio. Yesterday I did talk about CN and how the carbon and nitrogen are very important to the actual process of composting. Then they do an SME analysis, and they also do a MELEC3 analysis. Once matured, the piles are covered to protect them from contaminants and preserve the quality of the compost. It's OMRI certified, sieved with a star screen system. Runoff water from compost production is treated to protect the environment. Other components. Controlled release fertilizers, biofungicides such as root shield, actinoiron, gypsum, turfis, and many more. Many different components can be added to growing media for various reasons. However, the quality of these components can vary significantly and have a huge impact on results obtained by growers. Berger takes the extra step to ensure that every component falls within our strict quality ranges.